Hello everyone, welcome to another video on the introductory course to the operation research. In the last video, we looked at one of the very simple Excel example and we are going to build upon that example further complexity. So, in the last video, we saw that there is a manufacturer who produces the 4 products and it has 2 manufacturing units. Each of the manufacturing unit has a minimum capacity and the maximum capacity for each of the item at the manufacturing location. We also had the variable production cost, which is in dollar per unit, and we had the aggregated demand at the product level. We looked at the solution and we said that we'll apply the 3 constraints: minimum capacity constraint, maximum capacity constraint, and supply should be greater than or equal to the demand. We had one objective, which is to minimize the production cost. So we introduce a decision variable at the item and product level, which would recommend us how much to produce each product at the manufacturing location. So now if we go back to that and we click on the solve, we see that it has found a feasible solution which looks something like this. Then we said that let's change the data and see how it is performing. So let's reduce the max capacity and let's go back and solve it again. I'll just remove these values for the simplicity. Now once we go back to the solve, click on the solve, you see we get the solver could not find a feasible solution. Now in a real business case, even if the demand is greater than the available capacity, the plant would be producing to fulfill as much demand as possible. So our model should be built in such a way that whatever be the business case, it should give us a feasible solution, optimal feasible solution which is implementable. So how do we resolve these kind of the infeasibility? Now to reduce these kind of the infeasibility, there is a concept called slack and surplus variable. So let's look at that concept of the slack and surplus variable, and then we'll come back to the Excel file and we'll implement that concept. So what are the slack and surplus variables? See, the slack and surplus variables are, the artificial variable, or you can say the additional variable. And when we particularly talk about the slack variable, these variables are added when we have the constant in terms of the less than equals to, and these variables represent unused resources. For example, in 2x plus 1, 2x1 plus 5x2 less than equals to 50, to convert this into an equality, we can introduce a plus x3 variable in the equation, and this would become an equation of equality. So the x3 variable represent here the unused resources from this equation. Similar to that, we have a surplus variable, and surplus variables are introduced in greater than equals to constraint to convert into the equality, and they represent the amount by which the solution exceeds the resources. For example, 2x1 plus 5x2 should be greater than equals to 15. So here we introduce a surplus variable which is in terms of the minus x3, which should be converting this equation to equals to. The third type of the variables are the artificial variable. These variable has no economic or physical meaning, but they remove the infeasibility concept from the equations. For example, let's say we have an equation of 9x1 plus 15x2 equals to 34. So, and by introducing this constant, let's say our model becomes infeasible, then what we will do is we'll introduce a 2 variable plus x3 minus x3 plus x4 equals to 34. And then we'll penalize on these x3 and x4 in the objective functions to make sure the model is feasible. So overall, that's the concept of the slack and surplus variable, also the artificial variable. Now in our Excel example, we'll see how to implement these concepts to make this an feasible solution. So let's say we'll introduce this slack variable here. So I'll highlight this with red since this is again the variable for us. Now the constraint that we have here in the solver is, you see here, the E3, which is this column, which what we are saying is that if you look at this column, we are saying that supply should be greater than equals to the demand. Now in physical case, in this case, the data that we have, the maximum capacity at all the plant location that we have is less than the demand. So there is a higher demand than what we could produce in the next week, let's say. But to get a solution for this, what we will do is we introduce a slack variable. We introduce a slack variable here. Then what we will say is whatever the supply that we have plus the slack variable, we will drag this so that it's applicable for all the items. Now we need to introduce this slack cost in the objective function. So what we will do is we will take a big M method. For example, whatever the variable cost that we have here, we will take the max of that plus 1. So max of that cost from here we will take plus 1, so that this cost is significantly higher than all other costs in our objective function, and the slack variable only takes the value when it is necessary to remove the infeasibility from the model. So that becomes the slack cost for us. Now we will multiply this with all the slack variables. So I'll take the sum of all the slack variable here. This becomes the slack cost. What we will do is we'll add this slack cost in the objective function. So now the objective function consists of two terms. One is the variable cost, and the second cost is the dummy cost, which is the slack variable cost, and that would represent if we are not able to meet the demand, then how much we are not able to meet the demand. This slack variable represent that. So now let's go to the solver again and modify the demand supply constraint. So this was the demand and supply constraint. What we would do is we'll change this constraint. So instead of the supply, now this becomes our supply. Now we will change this variable to, let's say, the equals to, and the demand is this column. We'll click on the OK. We click on the solve. It still says the solver could not find a solution. So let's look at why. Right? There could be the cases now that, so there is a case now which says that we have the minimum capacity which has to be produced for the item B, which is greater than the total demand for the B. You see the demand for the minimum capacity for the item B is 240 and 150, but the total demand for B is 300. So it cannot exactly meet the demand. So what we will do is we will say we can produce more than the demand, and that will keep in the inventory. If that is the case, we click on the OK, click on the solve. It still says the solution could not find a feasible solution. Okay, so let's look at why the model is still infeasible. So if we go back here, so we see we introduced a new slack variable in the decision variable, but we did not include in the decision variable cell. So let's include that. Once we include this, and we have the constraints for us, all the three constraints along with this represent the variable with the slack variable, and if you click on the solve, it has found a feasible solution. So now you see the slack variable has taken the value of 20, and it says it can only supply the 420. The demand is 500, so it would be a shortfall of 20. This is how we can solve the infeasibility, by introducing the slack and surplus variable, and by taking those slack and surplus variable in the objective function as in dummy cost, and this becomes the supply plus slack or original equation. So that's about the concept of the slack and surplus variable, and how we can solve the infeasibilities in our model. And model should be good enough to solve all kind of the infeasibilities and give us a real output which should be implementable. Thank you.